If you have any doubts again, please unmute yourself and ask whenever I am talking. Please don't hesitate to ask. Okay, let us get started. Yesterday, we understood about linear regression and we created a model using linear regression. Today, I will quickly revise that linear regression and we will understand about logistic regression. In what scenarios we will use this logistic regression. And once we understand how this logistic regression works, we'll discuss about what is a neuron and what are actually neural networks. Then we'll slowly transition into quickly how these LLMs might have been created. We'll understand about various high-level architectures of these neural networks, and we will see how we came to transformer architecture based on which GPT was created. Okay, so that will give you a clear understanding, and after today's class, you will be able to clearly visualize how these LLMs might be working. Okay, just to give you an idea. So as I told you already, for agentic AI, for our actual topic, it is not required to understand about how these LLMs work. You don't need to understand about machine learning or deep learning or neural networks. You can just treat that model as a black box and we can consume the API exposed by that OpenAI and write our agents. But whatever I'm going to tell, it is just for our understanding so that we can visualize. Okay, so let us get started. It will be very interesting. So quickly, let me open a small presentation. Yesterday, I was running through this quickly. We understood about this linear regression. Yeah. So quickly, I will talk about logistic regression. But before that, I will revise whatever. Yesterday, we took a scenario about predicting the prices of home. We have a data which contains area of houses, number of bedrooms, and age of the house, and predict the price of the house. Based on area, number of bedrooms, and age, we understood how to predict the price of the house using linear regression. So I told you initially, if I have to predict area of price of the house based on area, I told you that I will plot this area and price on x-axis and y-axis, and I'll try to plot all the points and I'll try to find a best fit line. So if I can find a best fit line, which is actually crossing through all the data points, then once I get a line, what I can do for any given area, suppose if I want to get what is the price of this particular area, I can draw a vertical line and draw a horizontal line. Then I know the price for this particular area will be able to predict. So in linear regression, we understood that we have to predict this line. And we know the line equation y is equals to mx plus c. So in linear regression, our duty is to find the value of the best value of m and c. We understood that. But again, if I have to consider number of bedrooms and age also while predicting the prices, there are how many features? Area, bedroom, age, 3 features to predict price. So in this case, there are 4 columns, right? I need a 4D graph to actually plot. And again, in 4D graph also, we need to predict the line equation. The line equation will be something like this. Price is equals to M1 into area in this case, plus M2 into bedrooms, plus M3 into age. plus some C. So in this case, if I have all these features, I have to find the values for M1, M2, and M3 and C. And yesterday I told you clearly how to think about it. This M1 is nothing but the weightage which we are giving to area while predicting the price. M2 is nothing but the weightage we're giving to the number of bedrooms while predicting the price, like that. These M1, M2, M3, we can call them as weights. And in machine learning terminology, this C, we call it as bias. That means when all the weights are zeros, there will be some base price, is it? When all M1, M2, M3 are zero, this C is nothing but some base price. We call it as a bias, some base. Okay. So in machine learning, in linear regression, we understood how to find the weights and biases. Fine. So that's about linear regression. Now let me tell you another problem statement where I will introduce something called as logistic regression. This is very important to understand. Quickly, let us see. So I will just take this diagram and I'll try to explain this. In linear regression, we saw how to predict home prices. That means whatever values we are trying to predict, if they are continuous, then we can use linear regression algorithm. For example, if I have area and price, this is x-axis. X-axis can go infinitely on the right side. Y-axis can go infinitely like this. For any given area, I can find out the price. If I can somehow find out the best fit line, the line will go on. For any given x, I will be able to find the value of price. So the values are continuous. Then in such cases, we will use linear regression. So when to use linear regression algorithm to predict? When the predicted values are continuous, then we can use linear regression. For example, weather. If I want to find weather for today or tomorrow, or maybe after 1 year, I'll be able to predict the weather, or I'll be able to predict the stock prices also. So because I can predict for any future date, if the predicted values are continuous, then we can use linear regression. But if the predicted values are categorical, then I can use classification binary. This is called as a classification problem. For example, let's assume that I have an email text. I want to classify whether this email is a spam or not. So what should be the output after running my input email? Spam or not? Spam means 1, not spam means 0. So if I have an email text, my algorithm has to predict either 1, that means it is a spam, 0, not spam. So the predicted values are only 2. That means I have to classify my email as spam or not spam. This is an example of classification problem, right? And in this case, I have to classify either 1 or 2. This is called as binary classification. Given a text, I want to classify whether it is spam or not, either 1 or 2. 1 means spam, 0 means not spam. In this case of classification, we can use an algorithm called as logistic regression. Okay, we'll see more. And again, let us take another example, whether a customer will buy an insurance or not. Okay, whether a customer will buy an insurance or not might be dependent on various factors, like what is the age of the person and what is the education of the person, and maybe what is his income. Let's assume that I have this data. I want to predict whether a person will buy an insurance or not. Whether a person will buy an insurance or not is dependent on all this: education, age, and income. For example, definitely young people for less than 20, they don't buy an insurance. And maybe old people greater than probably 65, they don't buy an insurance. So whether a person will buy an insurance or not can be decided by age. And of course, if a person is not having income also, he will not buy an insurance because his income is less. And if the person is having good income and age also, if he doesn't have education about what is the importance of insurance, he will not buy. So whether a person will buy an insurance or not is dependent on all this. Here I want to classify: a person will buy means 1, not buy means 0. Simple. I have to classify the predicted value. The value that should be predicted is either 1 or 0. This is an example of binary classification. But what about the other one? Which party a person is going to vote for? Let's assume that there are 3 parties: Democratic Party, Republican Party, Independent Party. So we have to classify whether a person will vote for Democratic or Republican or Independent. That means we have to classify 3 values. So such type of classification problem is called as multi-class classification. Okay. So whatever, whether it is binary classification or multi-class classification, we can use logistic regression algorithm. Okay. Let us see how this logistic regression algorithm will work. Yeah, any doubts till now? We understood when to use linear regression and when to use logistic regression. Logistic regression is used for solving classification problems. That means when the predicted values are categorical, it has to be classified into some categories, 1 or 0, or here in this case, 3 categories are there. Then in such cases, it is a classification problem and we use logistic regression. Okay. Now,
yeah, Shiva. Shiva, in this case, during our first classes, we understood that uh, depending on our data set, we decide which ML algorithm to apply. But
depending
now,
upon what problem you want to
problem
solve
also,
also.
yes. So it is both data set plus the problem that we want to solve.
Of course, of course,
You
of
know,
course.
we will decide which algorithm to apply.
Exactly, exactly.
Got it. Got it. Yeah.
Okay. Shahid, tell me what is your query, Shahid?
Sure. Just we see in the linear regression, we have a bias, right? It's like a plus C. It was
Correct,
a
correct.
some kind of a error rate, like maybe say theta. Some it could be part of a
Not
bias.
an error, not an error actually.
Okay.
As I said, for in this case, for whenever we are predicting the house price, there are M1, M2, M3, right?
Yeah. Yeah.
When all these M1, M2, M3s are zeros, but there will be some base price, right?
Mm.
So
Some
whether
constant
house is
value.
there, whether there is house or not, there is land. There is some
Land.
base
Correct.
price for the land, right? So
Correct. Yeah.
that base price is nothing but some bias, initial value, I can say.
Initial
For
value
a
bias.
house, even if I don't construct a house, also there is an initial price.
Right. Right.
Yeah, you can think of it like that.
Understood. So in the same way, for our this logistic regression,
Mm.
if it's like as I said, it's a classification. So
Mm.
it doesn't have any something like default like 0 because suppose it could be have a 0 or 1. Is there any something like default here as well, similar to
No,
this
no, no. In
constant?
this case of binary classification, okay, we'll see. Just wait, just wait. We'll see how
Sure.
this actually will be calculated, how this logistic regression works. I will tell you.
Yeah. Yeah,
That
fine.
is the
Yeah.
next topic.
Yeah.
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 Okay. So what is logistic regression? Logistic regression is a technique used for solving the classification problems. Okay. As I told you, there are 2 types of classifications: binary classification, that means yes or no; multi-class classification, like this. Okay. So now let us see if I try to solve this logistic regression solve this classification problem with linear regression algorithm, what is the problem? Let us try to see first. Let's assume here in this case, I'm trying to plot whether a person will buy an insurance or not, only based on age right now, because it is a 2D graph. We cannot visualize a 4D graph if I say a person will buy an insurance based on age, education, and income. It will become a 4D graph. To make it simple for our discussion, let's assume that a person will buy an insurance or not is dependent on only age right now. Okay. So I plotted age on x-axis and the probabilities whether a person will have insurance or not on y-axis. So as it is binary classification, see there are only two values, 0 or 1. All the dots are either at 0 or 1. If I try to apply linear regression for this, see in linear regression what we do, we try to find a best fit line. It is not a perfect line, remember, it is a best fit line. So if I apply linear regression for this data also, yeah, the algorithm will find a best fit line. This is the line, for example. See, what do I mean by best fit line? For a line for which the error from all the data points is minimal, not zero, minimal. The errors from all the data points for this line is minimal. So definitely there will be one line which has a minimal error from all these points. So assume that this is the line. Okay. Now, how does it help for our binary classification problem? Okay, we can come up with some logic saying, hey, on y-axis, I will draw a horizontal line at 0.5. Okay, wherever this line intersects with my actual line, I can draw a vertical line here. So maybe this value, consider it as 42 in this case, right? So according to this, I can say if the predicted value is greater than 0.5, that means probably the person may buy insurance. So any value greater than 0.5, I can say the person probably, see, it's all about probabilities, probably will buy insurance. If the predicted value on y-axis is less than 0.5, then he will not buy an insurance. That's how I can predict. It's all about predictions. Nothing is perfect. Okay, that's fine. So according to this line, you can see these data points are classified correctly. When the value for the age 50, the value is here. Okay, 1, it's greater than, that's fine. But what about 40? There are some outliers in the data, right? Actually, according to the original data, a person bought an insurance at 40. But according to my logic, I have drawn a line at 0.5 and taken this 42. According to my logic, if the age is greater than 42, the value is greater than always 0.5 in this case, right? So according to my logic, if the person is having age greater than 42, then only he will buy the insurance. If I go according to this idea, for a person with age 40, according to my logic, it is saying he will not buy an insurance. But according to original data, he bought an insurance. So this doesn't look perfect. And also one of the problem is for a person with age 80, you can see the value is greater than 1 also. So actually, I want some probabilities between 0 and 1 only. If I draw a line, it is continuous. Even I can predict for age 200, what is the probability of buying an insurance? It will say that for age 200, the person will buy an insurance according to it. So having or predicting a line like this is not a solution for binary classification. What I need is all the values predicted should be between 0 and 1. I don't want to predict a line, but I want to predict some values between 0 to 1. Okay. Now the algorithm, let us enter into logistic regression algorithm. In logistic regression, how do we do? There are two steps in logistic regression. Let me just tell you the two steps in logistic regression. Yeah, let me take this. I'll explain you. If you want to apply logistic regression, that is a two-step process. First step involves finding the equation of line y is equals to mx plus b. This is step one. We'll predict y values based on, just like linear regression, I'll predict y value. Then step two is, once I predict the y value, I will pass it to a function. This is a formula. I can call this as a function called as sigmoid, because the scientist who found this formula, his name is sigmoid. We call this as sigmoid function. The function is 1 by 1 plus e minus y. E is a constant called as Euler's number. Just like pi is a constant. Pi is 3.14 something, right? Just like that, the value of E is also a constant, 2.7 something. It's a constant. So if I use this formula, y is substituted here. In the first step, we'll compute the value of y. And if I substitute it here, you can see, don't you think that the value of z is always less than 1? Because 1 by 1 plus something, definitely it will be less than 1. So once I calculate z and if I try to plot, the graph will look like this, where the maximum value of this z is 1 and minimum value is 0. Right? I'll get a graph like this. This is called as sigmoid. It is like an S shape, right? This is sigmoid curve. It is named after the scientist, right? So in this case, what we can do again, we can draw a horizontal line here and a vertical line here. Now, according to this graph, if I want to predict whether a person will buy an insurance or not, right now, according to this, maybe 38. According to this, what it is saying, if a person is having age greater than 38, he'll probably buy an insurance. And if the age is less than 38, he will not buy an insurance, right? Of course, there are some outliers. Here, a person bought an insurance for age less than around 25 also. There will be some outliers, but it is all about predictions. We'll try to predict. For most of the times, this will be successful. So this is the idea. We will get a value between 0 and 1 if I apply step 2. And what I will do is, according to my logic, if the value is greater than 0.5, the predicted value is greater than 0.5, I'll consider that the person will probably buy an insurance. And if it is less than 0.5, he will not buy an insurance. So this is the idea behind logistic regression. Yeah, any queries till now? Yeah, Shahid, you have raised your hand. What is your question, Shahid? Or is it previous one?
Sorry, Shiva, it was the previous one. I think I'm
Okay,
unable to lower down this.
okay. Fine. Okay, yeah. Any other queries from others?
Shiva, here in logistic regression, as
Hmm.
we know, we were earlier we were trying to like getting list errors. So in logistic regression, what we are trying to do that like every time this line will be like we will do like 0.5 only.
Yeah, according to logistic regression algorithm, the output of step 1, if I pass it to step 2, will always get a value between 0 and 1. And if you plot it, we'll get a curve like this. The maximum value is 1, right? So then once we have this, If we draw a line at 0.5 and find the value, according to logistic regression, we can say, okay, if the predicted value is greater than 0.5, I'll consider that value as 1, else
So
0.
it's like
Or
always,
you can
always I
think
should
of
take
you can think of this as a
1.5.
probability. Suppose if the value is 0.9, you can
Ah.
think that it is giving 90% confidence that a person will buy an insurance. Whether he'll buy an insurance or not, it is different. But this is giving me the probability. 0.9 means 90% confidence that this person will buy an insurance. If the value is 0.1, there is 10% confidence that he will buy an insurance. Mostly 10% means we can ignore it. He will not buy an insurance. So mostly we'll come to a point like 0.5 means 50%. Okay. If the value is greater than 50%, the probability of this person buying an insurance is greater than 50%. So we'll consider, okay, he may buy an insurance. May. But again, it is
Okay,
up to
now.
it is up to our logic. If we want to set this as 8.8, according to our logic, whenever we are writing our algorithm or configuring our algorithm, we can say if the predicted value is greater than 0.8, consider it as buying. Less than 0.8, consider it as not buying. It's up to us actually. But normally
Or we
I'm
can
saying
make
0.5.
like multiple also. Multiple like if it is like between 0 to 0.3, then show
Hmm.
some message or something from 0.3 to 0.5.
No.
Like,
Here it is not about message. It is either 1 or 0. That's all. I wanted to predict only two values. In this case, either 1 or 0. I want to predict. So whether it is
in
0.5 or
practical, there
0.8,
is
it is up to us.
Siva. Actually, in my company, what they did is a lead score for sales. Okay. So lead score, they used it because like lead is like, okay, it's a good quality, high quality lead or not.
Hmm.
So there they
Again,
have a
based on
score also.
performance only, right?
Hmm?
Again, based on this probability, right?
So now, but they have the score also. Score is like from 0 to 100.
Correct.
So, but they use the logistic regression.
Correct.
Because that is like there were 10 data points, different
Hmm.
different, based on like
Hmm.
from which channel source it has
Hmm.
come and
Correct.
from which
Correct.
country and all.
Now I'm saying based on age, I'm predicting. It can be
Mm-hmm.
multiple based on age or education, etc. We can predict the value.
So,
The
but there
output
it's
after
not like
logistic
0 or
regression gives a
1.
probability.
Yeah, but
Yeah.
it's not a 0 or 1. They are like giving us a score and stating the region like
See,
why we have given
finally,
it's a
output.
score
If
of
I
10
say
or
no,
15.
no, I'm saying suppose if I get a 0.895 as a value of y.
Okay.
Normally, I can give a score. Okay, for this, the score is 89.5. That is how they're converting and finally giving you the value.
Okay, understood. So it's not 0 1, but this value they are maybe outputting as a score.
You have
Okay.
to think that this is a probability. 0.895 means 89.5 probability.
Okay, understood. Thank you. Thank you.
Maybe if you want a between 1 to 10, you can say 8.9 is a value between 1 to 9, 1 to 10, 8.95, whatever. You can raise it to index 10 or 100 or whatever. It is up to us.
Okay. Okay. Thanks.
So
Yeah.
the index will go like 100, but we calculating only the 0 to 0.5 or 0.5 to 1 between only, right?
Correct. The logistic regression will always give you a value between 0 and 1.
0 and 1. Okay.
Now, if I want to consider it as 100, then I'll say 89.5% probability that a person will buy an insurance.
Correct. Yeah. That means there should be 89.5%. That means again calculation will be 0.5 and 0 to
Ah,
0.5 between.
correct. So for example, let's assume that I want to do multi-class classification. So number one, we have Democratic Party. Number two, we have Republican Party. And number three, we have some other party. Now what we do is, if I apply logistic regression for these three classes, either I have to predict 1, 2, or 3. Here there are three classes. Now, after running logistic regression algorithm, we'll get the probabilities of 1, 2, and 3. Let's assume that for 1, we get 0.8%, for 2, we get 0.6%, and for uh, third choice, I'll get 0.9%. Tell me, what should be the output after logistic regression in this case? 3.
It's a summation by
So,
3, divided by 3.
yeah, not divided. See, we'll get the probabilities. Okay, whether he'll vote for Democratic Party or not, it is 80% probability. Whether he'll vote for Republican Party or not, it is 60% probability. For some other party, it is
Sorry.
90%. So among all, what is the majority? So output of my logistic regression will be 3. In earlier case, binary, we have to predict only between 0 and 1, only 2 values. That's okay. But in case of multi-class classification, we'll just see the probabilities. Okay, the probability of third option is more. So the output should be 3. Like that, we'll classify. Okay, let us not get confused about multi-class classification, because again, you will get a lot of doubts. How can we get 3 values and all? Again, if in machine learning, again, there are different kinds of setups which we have to do for multi-class classification, binary class classification and all. But this, think about this only right now. Like right now, again, the discussion will go somewhere if we talk about multi-class classification. Yeah, I think somebody, Anand, I think your question is,
Yeah.
yeah, you can lower your hand.
Shiva, Shiva, actually, whatever the formula you have given it, right? So it will not depend upon the data, actually, whatever you give input.
Okay, see here, I am telling that this is predicting, but during training, we have to pass the data and train it, right?
Yes. So, like in that case, like y is the what are the input value, what are you giving it? I think earlier you said that the A's categorization is the pattern. That is a y is part of that value.
Okay, let me just tell you how this during training phase, how the weights are here. Also, weights are there, right? This M1 is a weight and B is a bias. Here also weights are there. Now, let me tell you in this step how the weights are calculated. I will tell you how will actually the training phase happen. I will tell you right now. Just wait. I explained it assuming that the weights are finalized. We will get the probabilities, but during training phase, what will happen? I will tell you. Okay. So this is my data. Let's assume that I have some data set where I have age, education, and income. I want to predict whether a person will buy an insurance or not. Okay. So in this case, what is step 1? Step 1 is to predict the value of y. The equation is y is equals to weight 1. I will not use M1 right now. I will use weight 1 into age plus weight 2 into education plus weight 3 into income plus some bias. So in first step, what I have to do, I have to find the values of weight 1, weight 2, weight 3 and bias. Then in second step, once I have the value of y, in step 2, what I will do, I will use a function z is equals to 1 by 1 plus e power minus 1. Then I'll get the value of z. Right. So now let us have a data. Let's say age is 42. Education is having 10 years of education and income is something, whether he bought a insurance or not, 1. Okay. Age is again 45. Education is 15 years and some income. Okay, 1. And age is 20. Education is 15 and some income. No. So like that, I have some data. Now, you have to think of logistic regression as a block of 2 steps. This is step 1, which is nothing but calculating y, and step 2, which is nothing but applying this function or applying this formula. Okay. You can think of logistic regression as this big block. Now what? We have to pass age, education, and income as three features. Age, education, and income. These are the three features we have to pass as inputs. Then finally we'll get a probability, right? Finally we'll get a probability. After this step 2, I'll get a value between 0 to 1. We'll get a probability. So assume that after I passed the first input, initially during training phase, these weights are initialized randomly. Please understand this importantly. Once we go to neural network, this understanding will become very important. Assume initially during training phase, these weights and biases are randomly initialized, right? So we'll have some random weights. Finally, once training is done, we'll have to finalize this weights, right? So assume that initially random weights, W is 2, W3 is 100, W2 is 100, and W3 is 1000, and maybe bias is some 200. Randomly, the algorithm will initialize this weights. Okay. Initially, these are the weights. Then what? First line, first input is passed. With these weights, Y is calculated. Y is passed to step 2. Assume that I got the value as 0.76. But actual value is what? Actual, this I will call it as Y. These all are X values. The value which I want to predict is Y. Y is 1, but actual after passing this input, I got the predicted value as 0.76. This I'll call it as Y dash. Y dash is a predicted value. Okay. But now, is there a loss or not? Actually, the value is 1, but the predicted value is 0.6. Now, do you want to consider loss as 1 minus 0.76? Do you want to consider this as loss? No. This is not the loss from the original value. Actually, when I was calculating linear regression, we understood loss will be calculated by delta square. The difference between the actual value and the predicted value is delta square. I'll sum it and divide by n. This I called as mean squared error. This was the function which I used for calculating the loss for the entire thing. But now here, when we are using logistic regression, this is not how we calculate. So there is something called as log loss. Again, there are very good reasoning why the scientists have used this log loss formula. Okay, for actually for this binary classification problem, or for the classification problem, the loss is calculated by using log loss. Let me tell you the formula of log loss. It is minus of Y into log of the predicted value. Predicted value means Y dash plus 1 minus Y into log of 1 minus Y dash. This is a formula to calculate the loss. Okay, don't ask me why this formula. In machine learning, there's a very good logic why they have applied this formula to calculate the loss. Right? This is called as log loss. Log loss, a loss which is using logarithmic values. So what is Y? Y is the actual value in our data set. What is Y dash? After passing these values, whatever we get is a predicted value, right? So in the for the first row, there is some loss. Second row, if I pass, again there will be some loss. Again, loss has to be calculated using this formula, right? So third row, loss. What we do is we pass all these data at once, each one by one to this algorithm, and we get total loss for all the rows. Suppose if there are 1,000 rows are there like this, we'll get total loss, right? This is loss for one row. We'll get, I have 1,000 rows. What I will do, I'll compute sum of all the losses and divide by 1,000. That is my mean loss. Okay. I've got some loss, mean loss. Then what? The algorithm will identify, oh, there is a loss. That means the weights are not correct. Then what the algorithm will do, it will adjust the values of W1, W2, W3. How to adjust the loss? How to adjust the weights? The value of weights will be calculated based on the mean loss. Again, there is a formula. It will use derivatives. This is loss, right? Total loss. This is total loss, right? Rate of change. This is actually using formula rate. I think if you know calculus, dou L by dou W1. So we'll calculate based on this loss calculated using some derivatives that weights will be recalculated. What should be W1, W2, W3? They will be recalculated. Again, once the weights are adjusted, again it will go through this process, right? Again it will go through the process. Then again weights are adjusted. Like that, the weights keep on adjusting. And after some n number of iterations, what we do is we finalize the values of W1, W2, W3. And our algorithm has a final weights. Like that, the logistic regression internally works. In this case, I wanted you to understand a terminology here. This loss value, whatever we calculate after first iteration, based on this loss value only, the weights W1, W2, W3 are calculated, and C also is calculated based on loss value. We say that the loss is back propagated. Loss is back propagated to get the final value, to get the adjusted values of weights. This process is called as back propagation, right? Yeah. Quickly, let me know if you have any queries till now. Yeah, this is a little bit complex. Any
So that's
doubts?
Basically, this
like
back propagation is work on the same formula, sure, like a y dot log of y, or is it a separate internal other formula is there for this back propagation?
Okay. Let me tell you exactly, maybe because because if I go into too detail, it will become a machine learning course where we are going on to with too details, but I will try to explain clearly or visually what do I mean by back propagation. I will tell you. Just wait. Yeah, I have two more questions from Nrsimha and Samsung. I'll take your questions. Just wait. I will answer this. Okay. See, this is my data, which is having age, income, and education, and whether a person will buy or not is a thing which we need to predict. Okay, I have multiple rows. This is 1, this is 0, this is something. Now what in logistic regression, you can think of logistic regression is containing two blocks. Step 1, where we calculate value of y, and step 2, where we pass it to sigmoid function. In step 1, we have to calculate y is equals to, that means whether a person will buy or not. I'll say it as y dash actually. The predicted value we call it as y dash. this actual value in the data is y. The predicted value is, in this case, but this is, let's say I'll call it as y. In this case, it is y. Y is equals to W1 into area plus W2 into income plus W3 into education plus C. Second is 1 by 1 plus e power minus z. Minus y, sorry. This is 1. Okay. So let us see. This is the algorithm, and we have to finalize the values of weight 1, weight 2, weight 3, and C. That's all right. If I can somehow find these values, this E is a constant. E is a constant. The output of this, we'll call it as y dash. This is the final predicted value, and this is y. Okay. Now, let's assume that I have 10 rows of data, for example. I'll pass age, income, education as input. And initially during training phase, I am telling this W1 is random value, W2, W3, and biases are initialized with random values in training phase. Finally, after training is done, our intention is to find the values of W1, W2, W3, right? Finally, initially they are random values. Okay. Now what with random values, once we give this input, first row as input, some y is calculated, right? And then and applying this formula, we'll get some y dash. Okay. So let's assume that the y dash is 0.76. We know the actual value is 1, but predicted value is 0.76. What is the loss? So the loss in this case is calculated using this formula, log loss. We are calling it as log loss. This is the formula. Yeah, this
Shiva,
is the formula.
sorry to interrupt. I have a question here. Like my question is on that. So you're saying like the W1, W2 will be randomly
Initialize.
assigned, right?
Initially,
Initialized. Yeah,
during
randomly
training
initial.
phase.
Yeah, during
Mm.
training phase. So if my Y value is greater than one, because like I'm randomly initializing, right? So will it omit those rows or like say,
No, no, no. After the final y is the original value, y dash is the predicted value. After
okay,
applying sigmoid function, definitely we know 1 by 1 plus e power minus y, right? The value will be always less than 1, 0, between 0 to 1.
no, Y dash is fine, but Y might be greater than
Y
one, right?
can be greater than 0. Y can be 1000, 10,000,
Okay.
anything. Finally,
Okay.
we are interested in y dash only. This is
Okay.
not y actually. Maybe you can say by, will buy. We don't get confused. Like this is actual y. This is something like ABC, you can think.
Okay.
Don't get
Mm.
confused. Don't get confused.
Okay. Yeah. Okay. Yeah. I got confused like how that.
Uh,
Okay. Got it. Mm.
yeah. So this is the formula using which we can calculate the loss. So y dash is, see, this is y dash. This is y. This is a formula. Why this formula? Again, scientists have identified this is a formula for, there is a reasoning, proper reasoning for this. If you learn machine learning, actually, I'm planning to start one more batch after this on machine learning and deep learning. But there is a logic. Just right now, this is the formula. If I apply this formula, maybe I'll get the loss as, let us say, 0.15. For example, I'm saying if I apply y is equals to 1, y dash is 0.6, I get 0.15. This is for first line. Second line, I'll get, let's say, 0.25. For third line, I'll get 0.4 as loss after applying this formula. So like that, for 10 lines of data, I'll calculate the loss and I'll calculate the mean of all the losses. Mean means what? Calculate the sum and divide by 10, we'll get the mean. Let us say mean loss or total loss, final loss is 0.3. This is a mean loss in first iteration. Okay. See, this is the loss function, right? This is loss function. So actually we have to calculate the W1 new. W1 was some random value, right? How to calculate W1 new is equals to the previous W1 minus something called as alpha. We'll see what is alpha into derivative of L with respect to partial derivative of loss with respect to W1. Okay, again, as I told you, this is calculus. Okay, this is calculus. So partial derivative of loss with W1. This alpha, we call it as learning rate. Okay. Learning rate, let us say 0.01. We'll give some value for it. So what I mean to say is the new value of weight 1 is calculated using some derivatives and some value. It is based on the loss, total loss also. It will give you some value based on this, right? Total loss. Okay. So the similarly W2 new is equals to W2 minus learning rate into partial derivative like this. Don't worry. So what I wanted you, don't worry about these formulas. Don't keep in your mind also. What I wanted you to understand is based on the loss function, based on the derivatives, the new weights are calculated. So I can say that based on the total loss value, finally, if I go to mathematics, based on this total loss calculated in first iteration, new weights are calculated. See, these new weights which are calculated are not just random weights based on some formula which is based on the losses. So I can say that this previous loss, based on previous loss, we are calculating the new weights, right? That means the loss is back propagated. The loss, whatever we get, is back propagated to the algorithm, and then new weights are calculated, right? So like that, this happens for n number of iterations, maybe 1,000 iterations or so. The loss is back propagated, weights are calculated, again we'll find the loss. So after some 1,000 iterations or so, this loss will become minimal. Whenever the loss becomes minimal, we will finalize W1, W2, W3, and C. So that is how it happens. I guess now you clearly are able to visualize what do I mean by back propagation. Yeah. Now I think I'll take the doubts. Yep.
Got it, Shiva. Yeah, thanks, Shiva. Yeah, understood.
Yeah. So yeah, I think Samsung and Suma, I think you raised your hands.
Yeah, sure. Basically, sorry, we have different formulas, right, for linear regression and logistic regression. So these formulas, like, meaning at which phase we have to use, either during test, meaning initially training phase or testing
As a
phase.
developer, do you worry about the formulas? You just create an object of linear regression. Similarly, you'll
Okay.
create logistic regression and you call model.fit just like this. Only two lines
Okay.
of code. See, the logic is you don't need to write the logic. Already they have developed the algorithms. The logic is already developed. Just I
Okay.
explained you how this works, but you don't need to do. You just have to call model.fit. Instead of linear regression, I'll create an object of logistic regression. That's all in your code.
Okay. 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 Got it. And second thing is, like, logistic regression is extension of linear regression, is what you mentioned, right, Shiva? Meaning
Internally, yeah,
it's
step one is
okay.
nothing but linear.
Okay. Okay.
And then applying sigmoid function and then calculating the loss. These all will make a difference.
Okay. Fine. Thank you.
Yeah, Samson, what is your query?
I already asked Shiva. I was
Okay.
confused between Y and
Okay.
Y dash.
Yeah. Maybe you can down your hand so that again I'll get clarity.
Okay.
Shiva Anand here. I
Shiva,
have one thing.
Ah,
Like the finally you come up with the value of y, right? So like you minimal loss that calculation accordingly you adjust the weight and all. So the point five, like in the graph initially we did with the point five is a graph, right? Maybe in the you can go to the previous. So that
finally,
point five. Hmm? Go ahead.
finally, see, once we finalize the final weight W1, W2, W3 and all, right?
Mhm. Yeah.
Once we finalize, then after finalizing, we'll try to plot this on the graph. What we
Okay.
get after, right, after final weights and all, we'll try to plot this y dash and all this on the graph. Then we will get we'll get a curve like this only.
Okay.
Then again, of course, finally after W1, W2 are calculated, the final output will be again a probability, right?
Understood. Okay.
Then
So the point
if
five,
I,
like what are the graph you are giving it? It is that's a prediction score, what your expectation actually.
exactly. So maybe after finalizing the values of weights and whenever I'm trying to predict, I got 0.8 0.8 means 80% probability that this person will buy an insurance.
Okay.
It's a probability. That's all. Okay.
So Shiva, in this case, that means in logistic regression during the training phase, it's only the step one that is getting
Step one,
performed.
step two, both are calculated, right?
Okay, step one and step two both are getting calculated.
Step one and step two are calculated, then only I'll get y dash. I have y and y
Okay.
dash. I'll use this formula to calculate the loss. This
Okay,
loss function is different for linear regression and logistic regression.
got it. Okay. So so okay. So that means if I start with some random value of W1, W2, W3, I'll perform my step one as well as my step two to get that white dash, and then I'll perform the same for
For all the rows in one
all the
iteration, you'll go through all
datasets.
rows. You'll get the mean
Then
loss.
okay.
Once you get mean loss, it's back propagated. New
Back.
weights are calculated based on the actual loss using some
Understood.
formula.
Yeah,
So that means you're
got it.
back propagating the loss and calculating the new weights. So like that, adjusting weights will go on, go on, go on. Maybe for after 1,000 iterations or so, when the loss will become minimal, we'll finalize the algorithm. Will finalize the W1,
Weights.
W2. Yeah.
Got it. Yeah. Okay.
Yeah,
Thanks.
Ramchandra, tell me.
So, in this, I mean, this is a way of actually finding out a probability, right, of whether we bet. So once you go through this, hundreds of and thousands of iterations, can I consider that, for this type of a problem, okay, the we can start using this specific logic. I mean, with those W's, final W's that you've got it. Can we say that, hey, I've built a model now? Anyone who's having
Yes.
this question
If anybody
has
wants
this
to,
problem.
yeah, if anybody wants to predict whether a person will buy an insurance based on age, income, and education, use my model. Once, see, how do I create? Instead of linear regression, I'll just use logistic regression here. And we call model.fit exactly same way. Then we have a trained model. Dot coefficients will give you weight 1, weight 2, weight 3. Dot intercept will give you weight, the intercept. Same. Concept is same. So once we have a
Yep.
trained model, if anybody gives me age of a person, income of a person, and education of the person, if I call model.predict, I'll get the probabilities. Now in this case. Okay. Yeah. Fine. Yeah. Durga Prasad, you have any
Yeah,
query?
I think but like everything is good, but if the problem the problem here is if we have the bad data, if you give the bad data and train the model in a bad way, whatever
The
you did
quality of
all
your
is
model depends on the training.
exactly. So if the data is bad, then model is bad, and your
Prediction
predictions are
will be
wrong.
bad. Of course,
So
prediction will be.
in the end, it's all comes to the. I know these formulas are all there already predefined, so we don't need to worry about. Here, main thing is giving the good data.
Data.
Okay, so and I have my question is like, so after we have the final W1, W2, and W23, we have the formula, right? So at this moment, we have the final formula. So what is the next step? Like for predictions, we give the, for example, if I give some values, then do we need to do all the step one and step two?
No, see. Wait. I explained you the logic. If you as a developer wants to do training, you just create an object of logistic regression. Yesterday I showed you linear regression, right? Instead of linear regression, you create an object of logistic regression. Call fit. Our training is done. Whatever I said, the logic, it is taken care in the fit method. Once I call fit, weights are calculated, everything is done. Then you can use this trained model to do predictions just like this. If you pass the input data, you will get the predictions.
Okay. So in this case, it's not a numerical value, but it is it a numerical value or is it a yes or no value?
Here in this case, it is value between 0 and 1. In case of logistic regression, it is always a value between 0 and 1. It might be, let's say, 0.85. That means 85% probability that this person will buy an insurance.
Okay, got it. Yeah.
Yeah, Deepak, tell me, Deepak.
So Shiva, going back to your original example, right, on the insurance buying prediction. So largely, right, as we discovered or as we know, right, the efficiency of a model, primarily is determined by the training data, correct?
Data.
Because see, most of these models, right, I believe would use the same mathematical functions, right, in arriving at the right coefficients, correct, or the weightages, right? Now, let's say there's an executive in an insurance company who would like to use some kind of model, LLM model, right?
So, okay, wait. This is not an LLM. We didn't go up to LLMs. We are just understanding how a model will look like. We are not going with LLM. Till our discussion didn't go up to LLM. This is just a machine learning model. Just in this case, we are trying to predict. That's all. Predict the probabilities.
Okay.
I'll take you to LLM. That is different.
Okay. Okay. So basically, okay, I'm going a step ahead. So how does an executive determine which model to use, right? I think most of the LLMs would use a similar kind of models, right? And it all depends on the training data sets, correct?
Wait. Here, don't even take this LLM into picture. That is totally different. What we have is, as in our organization, we have huge data in your database, whatever. So we want to do some predictions based on our existing data. In this case, I want to do prediction whether a person will buy an insurance or not. So I want to train a model. I want a trained model to be created. So in my organization, I gave a requirement. Hey, somebody perform a training and create and give me a model. So some executive, a machine learning engineer, he will decide, oh, what type of predictions I have to do, whether a person will buy or not buy. Oh, it is a classification problem. The machine learning engineer will understand, okay, this is a classification problem. If it is classification problem, what algorithm to use? Logistic regression algorithm. He will conclude. This logistic regression is exactly same, right? Whatever is the data, you want to do classifications, whether you want to do classification for insurance or you want to do classification for some other type of things, whatever is your use case. It is a binary classification, or your machine learning engineer will understand, okay, this is a classification problem. The algorithm to be used is logistic regression. Then he will write a code like this. Instead of linear regression, whichever I showed yesterday, here you'll use logistic regression and call model.fit and pass this X and Y. This X and Y is a training data, whatever we have, this data, right? Then the model will get trained automatically, whatever, and the weights are finalized. Weights and biases are finalized. So that means I have a trained model.
It is all based on the internal organization data and to arrive upon an internal model without even using an external model, correct?
Now don't even think about LLM. We didn't come to LLM till now.
Okay. Got it. Okay.
Okay, fine. Connor, tell me, Connor, quickly.
So, Siva, so look, it's okay when we have a less data, but if it is a single machine, there is huge data, this calculation or the way we are doing, I think it will
take a lot
be a
of time.
separate. So means parallel machine will run or means just what will be the approach there?
Yeah, so that's what we are saying. Machine learning is very costly in terms of computation. It takes a lot of CPUs. Actual CPUs are not good. GPUs, you need GPUs. A lot of computation is there. So you are asking whether you wanted to go for distributed computing. Instead of computing on a single machine, you want to go with distributed
Yeah,
computing.
because
No,
it is not possible with a single machine to calculate all this if it is a huge data set.
no, distributed computing in this case will not work. I have not seen any model which uses distributed computing because this all
Hmm.
loss calculation for each and every row
Yes,
and going
yes,
through iteration is a single process. It has to be done by a single
yes,
process. So distributed computing is not possible. This will execute on a machine, and that machine
single
should have
machine.
high computing power.
High
That's a
computing.
basic requirement of any machine learning, high computation power and memory. So distributed
Okay,
computing is
thanks.
not possible in this case.
Yeah, okay, thanks.
Okay, okay, good. So we understood about logistic regression, right? Now let me tell you here, if training is done, let's assume that training is done for my model. You can think of this round, this circle as a trained logistic regression model. This is step one, this is step two, and finally we'll get a probability if I pass the input, right? I can think of this block as one neuron. Let me introduce you to what is a neuron. This block in logistic regression, whatever I am using, this block is a neuron, right? Now, in neuron, there are two steps. First is calculating the value of y using whatever formula, and second step is applying. In this case, this formula is called a sigmoid function. Name of the scientist is sigmoid, so it is called a sigmoid function. The output of sigmoid function is a probability between 1 and 0. Okay. Sigmoid function, I can say that if I give some input, I can say that if the value is less than 0.5, person will not buy an insurance. Greater than 0.5, in this case, person will buy an insurance, right? So what I will do is I'll convert this probabilities into either 1 or 0 based on the value, based on my logic. This 0.5 is not a standard. You can think of just 0.8 if you want in your use case. Okay. Based on some value, you will categorize it either as 1 or 0. Right. Okay. I can say that this block is a neuron. I can say that this neuron is activated. The neuron is activated if the value is 1. If the value is 0, I can say that neuron is deactivated. Okay. So whether a neuron will be in activated state or a deactivated state is defined by this function, right? In this case, it's sigmoid function. We call this also as activation function. Okay. Sigmoid is just one of the activation function. There are a lot of other activation functions. In machine learning, there are different activation functions based on the scenario. Again, we can use one of the activation function, but just understand that this is an activation function. And this neuron can be either in active state or inactive state once we pass some input. Okay, now let me answer your question in your minds. Why the name neuron? Why are we calling it as neuron? What do I mean that neuron is activated or deactivated? Let me connect all the dots. Okay. So just it is very interesting discussion. Let us see why the name, why they gave the name as neuron. See, it's equal to our human brain. In our human brain also, we have a lot of neurons connected with each other, is it? Lot of neurons. So let's assume that this is a brain and each dot is a neuron for now. Let's assume that I see a bus with my eyes. I see a bus with my eyes. My eyes will send a signal to my brain. Some signal whenever my eyes see a bus, it will send a signal. Whenever a signal comes to my brain, maybe in my brain, this neuron got is activated and it got connected to this neuron. And maybe this neuron got connected to this neuron, and this neuron might get connected to this neuron. So whenever a signal comes to my brain, some neurons will activate and they will connect to the next neurons to next neurons like this. Okay. For the first time, whenever my brain sees a bus and my eyes send a signal to my brain, these neurons got connected, and to my brain, I said, okay, this is a bus. My brain will understand, oh, if these neurons are getting connected, when I get a signal, this is probably a bus. Now I'll see another type of bus. There are different types of buses, right? I'll see another type of bus. Okay, again, the signal will go from my eyes to the brain. But this time, maybe this neuron got connected, this neuron got connected, and this neuron got connected. This time when second bus is seen. Oh, then my bus will identify, okay, if these neurons gets connected also, this is a bus. So my brain is trained from my childhood, our brains are trained with these signals so that if some neurons are getting connected, okay, if these neurons gets connected, my brain will identify this is a bus. Maybe if I see a car, right? If I see a car, some other neurons will get connected in my brain. Okay, if these neurons are getting connected, okay, I have to identify this as a car. So my brain is getting trained from my childhood. So based on the neurons only, my brain will identify what is a bus, what is a car, what is a phone, etc. Right? Our neurons gets connected to take a final decision. What is the output, whether it is a bus or a car or whatever, right? So I want you to understand that neurons get activated based on signal, right? Now, suppose if these are the neurons in my brain, sometimes in my brain, whenever my brain sees a new car, a new bus, maybe there is a light connection between these neurons and there's a strong connection between these neurons. I'm writing a thick line, strong connection, light connection. Maybe between the neurons, there might be a strong connection with represented by thick line, or there might be a light connection, right? So whenever our eyes send a signal to the brain, of course, neurons will get connected, right? So after seeing 1,000 buses, for the first time these neurons got connected. Let us say among 1,000 buses, 900 times, when my brain recognized this as a bus, the connection between these neurons was always there. In 900 times, the connection between these two neurons was established. Out of 1,000 times, this got established. So I can say that if these two neurons are connected whenever I see a new bus, there's a 90% probability that this is a bus. My brain will identify. Again, that's all probabilities. Got my point? Whenever I say a new bus, how does my brain identify this is a bus or not? During the training phase, out of 1,000 buses, whenever I saw 1,000 buses, 900 times these neurons got connected earlier. So that means my brain will identify 900 times these neurons got connected whenever I saw a bus. If I see a new bus and if these two neurons are getting connected like this, there is 90% probability that this image is a bus. Got my point? Please let me know if you are getting confused. I'm talking about brain. How my brain will actually learn, just like machines are learning. If I show 1,000 buses, 900 times, these neurons got connected. Oh, next time whenever I see a new bus, if these two neurons are getting connected, my brain will think, oh, 90% this looks like a bus. Okay, that's how it is. So fine. Now, if I think about neurons, suppose if I have one neuron and this is another neuron, the output of this neuron is going to another neuron. The output of this neuron is 0.95. That means this connection, that means this neuron is activated 95%. 95% activation is there for this neuron, output of this neuron. Okay, forget about the second neuron. Okay, let us, for clarity, let's take one single neuron. If I give some input to this neuron in my code, if I get 0.95 value, that means this neuron is 95% activated. If I get 0.15, that means it is 15% activated. So whether a neuron will getting activated or not is defined by this activation function, right? Yeah. Right now, till now, in our code, I have shown you single neuron. Now let me talk about a very interesting thing, neural network. What is a neural network and why do we need this neural network? Let us try to understand this point. Very important and interesting thing. Please concentrate. And if you are having any problem in your understanding, please ask me again. Okay. Why neural network? See, one neuron, if I give some input, it is giving a probability, maybe 0.85 or whatever. Neuron will always give a probability. But again, probability means probability. It is not an actual, it cannot be 100% guaranteed, right? Now think about this. Without giving a technical example, let me give a non-technical example before I go and discuss about neural network. Let's assume that I want to buy a phone. A non-technical example I'm giving. I want to buy a phone. I have a budget of 50,000. But I am not a person who knows about phone features. I don't know which phone is good. So when I don't know, when I can't decide which phone to buy, whether I should buy iPhone or maybe Samsung or maybe Oppo or whatever, which phone is good? I have money, that's all. I have 50,000 budget, 50,000 rupees budget, not dollars. Okay. What phone to buy? As I don't know about phone features, I went to my brother, who is an expert. He knows about all phone features. And asked, hey brother, I have 50,000 budget. Can you suggest me a good phone? I want a camera. I want camera more. For me, camera is very important for me. Tell me, what phone should I go with? My brother will say, hey, go with iPhone. But if I go with iPhone for this 50,000, what is the probability that my decision will be a correct decision? Maybe with 50,000 budget, I'll get even a better phone with better features than iPhone in this budget, right? So if I take the help of one person, he might be biased over iPhone. He might like iPhone, so he suggested me iPhone, but that decision might not be correct. So now the idea is, instead of asking one person, I'll go to 10 different persons and ask, hey, give me your score. I have iPhone, Samsung, and Oppo. Give me your scores. Each person has to give, okay, I will vote 85 points for iPhone, 65.5 Samsung, and 90 points for Oppo. Let's assume that the first person gives this scores. Second person I'll ask, he will give his scores for all. Third person, fourth person. If I ask 10 persons, I can get a mean score for iPhone, mean score for Samsung, and mean score for Oppo. Then based on this, if I take a decision, don't you think that the probability of my decision being correct will be more? Yes. You can think of each person as a neuron in this case, and each person is giving their probabilities. If I take the opinion of multiple neurons, my probability of being correct will be more. This is a non-technical example, right? Okay. Let me just take one more non-technical example to explain you. I have taken it from a very good website. This is not my thing. I just want to credit. There is one person from whom I borrowed this idea. It's a very good idea. I'll explain you. And again, a non-technical example so that you will appreciate the concept of neural network. I have another 5 to 10 minutes I will take. Just give an overview. Tomorrow we'll continue. I thought of completing this neural network today, but let us not rush. Okay, fine. Let me tell you. See, let's assume that I want to predict. If I'm given a image, I want to predict what is this image. Actually, if you know, what is this image? What is this animal?
A koala.
Koala, correct. Okay, it's a koala. So if I give the image, I want to predict whether this is koala or not. So just see, let's assume that I have three persons, Mike, Mohan, and Saki. Mike is an expert. He can see eyes of this and predict whether this is koala or not. Mohan is an expert. By just seeing a nose, he can predict whether this is a koala or not. And Sakib, he is good. By seeing ears, he can predict whether this is koala or not. Okay. Now there are three persons who can give their predictions based on various features. By seeing eyes, Mike will give. By seeing nose, Mohan will give. By seeing ears, Sakib will give. So again, each person will give a probability that this is a koala or not. So assume that Mike is giving 0.8%. That means 80% probability. Mohan is giving 0.9 and Sakib is giving 0.6 as a probability that this is a koala based on these features. Now another person, Serena, will take these inputs. Okay. Now, Serena knows about Mike, Mohan, and Sakib. Based on Serena's experience, this Mike is correct only 20% of the times. See, earlier during training phase also, maybe whenever he has seen multiple images, whatever predictions he gave, 20% of times only Mike was correct. And Mohan was correct based on the past experience. Mohan was correct 50% of the time. And Sakib was correct based on past data 33% of the time he was correct. So when Serena has got this scores, Serena will understand, hey, I'll give 0.2 weightage to Mike. I'll give 0.5 weightage to Serena's prediction and 0.33 weightage to Sakib's prediction. Based on the past experience, Serena is giving some weightages to their prediction. Then based on the predictions, Serena is calculating for ice means Mike, 0.2, 0.5, 0.33. These are called as weights, right? In our terminology, weights. So applying this formula 0.8 into 2, 0.9 into the values, we got 0.79. So Serena can say, Serena can say, okay, this image is 79% koala, but it is taking its decision based on these three people, right? You can consider each person as a neuron and the value they are giving as probabilities, right? And Serena, based on her experience with Mike, Mohan, and Sakib, she has given weightages. Okay, I'll give Mike 20% weightage. I'll give that means 0.2. Mohan, okay, he was 50% of times he was correct, so I'll give 50% weightage to his value. So like that, Serena has calculated. So this is a final weight. So now if you think each person has one neuron, don't you think that instead of using single neuron and doing a prediction, if I can create multiple neurons like this and do predictions, the probability will be much more better. Is it? Do you agree? Let me know if you have any queries in this one.
But value should be always to 1 or weightage for all the weightage if I sum up.
No.
Means,
It need not be. It need not be. Maybe you can say, okay, 3, you can think. Just I give random values, okay?
No, it's fine. Means as a means understanding purpose, example is
You
fine,
can,
but I think it will be 1 only because it's a probability. So
correct.
total
No.
1 and like that.
Total value should be less than 1. I
Yeah.
guess I guess it makes sense that
weightage.
the total weightages should be 1. Yes, I guess it makes sense.
Yeah,
Yes.
because it's a because now I am thinking in terms of that you have given that example of multi-classification of Democrat, Republicans, and the Independent Party. So maybe we can think of that as a 3 neurons. Means let's say
Correct. Correct.
so I'm just trying to uh, thought of like let's say there are 3 data points X, Y, Z, and then there is a final column where we have the past data that this person voted for which party. So based on if I do a classy that multi-class I'm going, and then that logistic regression if I will apply to X only for a X factor, and then based on this X data, let's say religion or something, this person voted for Democrat. Now, based on this X factor, it's this particular neuron is let's say 50% right. So I will give a weight of like okay 0.5, because not all the time, because I'm calculating based on X only.
Yeah.
Then for Y and then
Actually,
for Z. Is
yeah,
it
yeah.
like something you are trying to?
No. Actually, for multi-class classification, this arrangement of neural network will be different. Right now, I'm talking only for binary classification. This arrangement of neurons or the formation of neural network will be different for multi-class classification. Maybe
Okay,
let us not get
so
confused. I'll tell you later.
okay,
Let us
okay.
not
So
get
that buy
confused.
insurance or not for that. So maybe for
Only
buy
for binary
insurance or not.
classification, this is
Hmm.
whether it is call or not, yes or no, that's all. Whatever example I told is only for yes or no, binary.
Okay, okay.
So for multi-class classification using this multiple neurons, we have to configure this set of neurons in a different way. Okay, maybe let us not get confused. This is the one, right? So fine. Let me just conclude with last example. Maybe for today time is over. So last example I'll tell you and I'll conclude. Now what? Again, I'll add this. Instead of using like this, now see here, another non-technical example. Serena, Mike, Mohan, and Sakib. This Mike is good at predicting based on eyes. This Mohan is good at predicting based on nose. And this Sakib is good at predicting based on ears. So these all can predict based on face features. These 3 people can predict based on face features. And this Jyoti can predict based on body. And this Chen based on legs, he can predict. Right. So now just a non-technical example I'm giving. So these 3 will report to Serena, and Serena will give the probability that the image face is call or not. This is face prediction. Face is one feature of the image. Face prediction is given by Serena. And based on Jyoti is predicting whether it is call or not based on body. Chen is predicting based on legs. They will give their predictions to Nidhi. Just like Serena calculated, Serena will give her predictions based on these 2. And this is body prediction. Okay. Let's assume that Serena gave 0.76 as a probability and Nidhi gave 0.66 as a probability. Now Sergey is calculating, getting the values from Sergey, Serena and Nidhi. Okay, according to experience of Sergey, Serena was right 60% of times, for example, and Nidhi was right 40% of times. So he will give 0.6 weightage to Serena, 0.4 weightage to Nidhi, and then he will do his calculation. So Sergey will finally tell whether this is call or not. Hey, in this case, this is layer 1 of neurons. This is layer 2 of neurons. This is layer 3 of neurons. If I have multiple layered neural network, then my predictions will be even better, right? So this is a non-technical example which I gave today. If I can create neural networks, we'll see technically tomorrow. if I can create network of neurons, my probability of predictions will be great, right? So tomorrow we'll continue from the same point and we'll have a detailed discussion on neural networks, how these neural networks work, and then slowly come to how LLMs might work. Right? Tomorrow we'll complete this and we'll start with a basic program where I will start using my first OpenAI API to do some predictions. Tomorrow we'll complete this. I thought of completing it today, but that's okay. I hope I am not rushing. Making sure that you understand all the concepts clearly is important, right? So I can say in this entire training today is the toughest theoretical part. I wanted you to go back and see this video again and come up with your queries tomorrow. We can have a good discussion tomorrow. Let us not rush. I promise you, I will not rush at any point. I'll go at this pace, even though whether it takes more than 2 months or 60 hours for 70 hours, I'll make sure that I'll complete. Learning is very important, right? Let us not rush. That's all. I'll stop for today.
Thank you.
Yeah,
Thank you.